Good morning, students. Today we are going to discuss about comparing attribute selection measures. See, till now we discussed about like information gain ratio, and then Gini index. We are comparing with these like whatever the attribute selection measures we discussed till now. See, the three measures in general return good results, but information gain it concentrates towards multi-valued attribute. As you all know that information gain concentrating a multi like value attribute is nothing but whatever the attribute we are facing in given database. If that attribute concentrates larger value, obviously that thing can be acts as a splitting attribute here. Because of that reason, like obviously here information gain is concentrating multi valued attribute to check which one got highest value to like split the contents. And then gain ratio tends to prefer unbalanced splits in which one partition is much smaller than the others. This is about gain ratio. And then Gini index biased, this is also concentrating like multi-valued attributes, has difficulty when number of classes like is large. Then obviously we are facing difficulties over there. Tends to favor tests that result in equal sized partitions and purity in both partitions. This is about a Gini index. Then other attribute selection measures, we have CHAID. This is a popular decision tree algorithm measures based on chi-square test for independence. This CHAID uses like chi-square test based on to solve a certain kinds of problems based on this particular chi-square test. Then CSEP performs better than information gain and Gini index in certain cases. Then G statistics has a close approximation to chi-square like x-square distribution. Then MDL, minimal description length principle, that is the simplest solution is prefer the best tree as the one that requires the fewest hash is nothing but here number of bits to both one encode the tree and two encode the exceptions to the tree. It concentrates two things. First it will going to encode the tree and then encode the exceptions of the tree. Then multivariate splits, partition based on multiple variable combination. It contains like multivariate splits is concentrating combination splits based on your particular attribute values. Here CART finds multivariate splits based on a linear combination of attributes. Which attribute selection measure is the best? Most give good result, none is significantly superior than others. Because as we till now we discussed about information gain, Gini index and gain ratio, and then like this CHAID, CSEP, G statistics, MDL, CART, these are like measures are going to give good results, but no one can like none is significantly superior than others, because obviously each and every things are equal, because each and every attribute selections measures giving good results based on their this thing like that, but it will not going to reach like significantly superior than others. The next concept is overfitting and tree pruning. First of all, tree pruning, as you know that pruning is nothing but cutting, like removing the things. Here overfitting, an induced tree may overfit the training data. Too many branches, some may reflect anomalies due to noise or outliers. As you all know that outliers is nothing but unwanted information. Noise is also same thing here. If the things are fitted over there, then obviously those things can also act as certain kinds of branches. Obviously we'll get like poor results. Obviously if unwanted informations are present, means obviously there is no quality of information. Because of that reason we need to remove such kinds of informations here, like poor accuracy for unseen samples. As I told that, like lack of there is no quality in that particular information. So two approaches to avoid overfitting: pre-pruning and then post-pruning. Pre-pruning is nothing but like before going to building, the thing will going to prune the things. Like halt tree construction early. Do not split a node if this would result in the goodness measure falling below a threshold. Difficult to choose an appropriate threshold. This is about pre-pruning. See, before going to construct, if the things are as content contains certain kinds of noises, outliers, obviously we need to prune there itself. Then post pruning: remove branches from a fully grown tree. See, once you construct it, after that, post is nothing but after the things are completely constructed, the tree is completely constructed, then obviously we need to get a sequence of progressively pruned trees. Use a set of data different from the training data to decide which is the best pruned tree. This is about overfitting and then tree pruning. Then again, enhancements to basic decision tree induction. We have allow for continuous valued attributes. As I told that the things are not discrete here. Dynamically define new discrete valued attributes that partition the continuous attribute value into a discrete set of intervals. Handle missing attribute values. See, we are going to assign the most common value of the attribute, assign the probability to each of the possible values. See, handle missing attribute values is nothing but we are going to assign some certain kinds of relevant values, like some whatever the values we faced, like there is a relationship between to that particular attribute. Such kinds of values we need to enter. We need to assign the most common value of the attribute. Assign probability to each of the possible values. We need to guess the things, and then based on the probability to each of the possible values. So such kinds of values we need to assign to that particular missing attribute values. Then attribute constructions. First, initially, create a new attributes based on existing ones that are sparsely represented. This reduces fragmentation, repetition, and replication. See, attribute construction will reduce the fragmentation. Fragmentation is nothing but the way how we are dividing the things. Repetition is nothing but it will avoid some certain kinds of whatever the information, the things are repeated over there. Then again, replication is nothing but replication same things, the things are derived. Obviously replicas is nothing but same informations. Such kinds of things we can avoid, we can reduce based on this particular attribute constructions. This is about enhancements to basic decision tree inductions. Thank you.